database programming. I am your host, SQL Trevor. In this episode, I will introduce you to SQL Server Management Studio. This is the primary tool Microsoft developed for working with SQL Server databases. I will demonstrate how to connect to an instance of SQL Server, also called a database engine. I will demonstrate how to create a database using Management Studio. Additionally, I will also demonstrate how to create a database using Transact SQL. Bear in mind that the purpose of this course is to teach SQL programming. And in order for you to learn SQL, you must write code in structured query language. Let's begin. Okay, let's begin by Server Management Studio version 22. This comes with the newest version of SQL Server, which is version 2025. When you first launch Management Studio, it opens with the Connect dialog window. And this is where you would normally connect to a SQL Server instance or a SQL Server database engine. Now, to the left, you'll notice it says server name. And this is important because we need to understand exactly what server name really means. Server name at this point is referring to the name of the physical machine itself. I'll demonstrate. If we go here and we type in sysinfo, you'll notice that the system name is app developer. This is the system that is hosting the installations of SQL Server. Now, when we go back to Management Studio, now I close the Connect dialog window, but normally what I do after closing it is simply go to View and select Registered Servers. On the Registered Servers, we go to Database Engine and we select the local server groups. Under the local server groups, it will list all the various installations of SQL Server, or as they are called, the various database engines that are installed. And at this point, it's listing 3. The first one, again, lists the name of the physical server itself, which is app developer. This tells me that it is the default instance or the default database engine. The default instance always assumes the name of the physical server, and that's how you know it's the default. Whereas these other two concatenate the name of the server with the name of the instance or the name of this named database engine, which in this case is ML SQL Server 01. So it's app developer / MS SQL Server 01. The other does the same thing, which is app developer / SQL Express. These are separate engines. These are separate instances. And in order for you to access these, you would have to give it the full server name, that is the joined or concatenated name, which is the name of the actual physical machine combined with the name of the instance. So, having said that, we now will demonstrate how you connect to a particular instance, or as it's called, a database engine. So let's go to View again and select Object Explorer. Object Explorer, we select Connect, and we go to Database Engine. Again, we have the Connect dialog window reappear, and it defaults to the very first database engine, which again I said it's called App Developer. So if you wanted to connect at this point, what you would simply do is go to Connect, click on Connect. However, if you don't want to connect using this particular engine, but you want it to connect to a different engine, you simply go to Browse, go to Local, and under Local, it will list all the instances or all the database engines that are up, not necessarily running, but that are installed on this machine. So as you can see, there are 4. App Developer, which is the default, App Developer / SQL Express, App Developer MS SQL Server 01, and App Developer / SQL Express 01. And to connect to any of these database engines, you would simply select it, and of course you must select Trust Server Certificate, then you connect. So we're going to go with App Developer, the default, and we're going to select Trust Certificate and connect. And there we have connection. So now we've interfaced with this particular database engine, or as it's called, this particular instance of SQL Server. Remember, there are 4 separate instances running, and each database engine runs as a service on the machine. I'll demonstrate. If we go to Win+R and just launch the management console for services, under services we have a listing of all the services that are running on this machine, and over here it shows SQL Server, and it also shows SQL Server Agent, it also shows SQL Server Browser, so on and so forth. All of these are related to all SQL Server services that are running. This is SQL Server. This is SQL Server 01. This is SQL Server Express, and this is SQL Server Express 01. Those are 4 separate database engines, and with each engine there is an associated SQL Server agent. I'll explain what the agent does later, but as you can see, for every named instance or database engine, there is also a named SQL Server agent here, here, and here. Okay, so now that I've demonstrated that, we go back to this instance, and I want to expand the databases folder, and under this folder you'll see several databases that are known as user-defined databases, meaning that these were created. These are not SQL Server databases. These are databases that are created by the user. 2 of these are mine. I actually created these 2. My eLibrary database and the GUI database, which is a construction management database. And also these other 2, TestDB, which is just temporary, and TestDB2, which is temporary. I just did that for demonstration purposes. But the first one, AdventureWorks, is a well-known, very famous database that Microsoft developed and used and I believe still uses for all its training purposes. It's a well-known database, and followed by T SQL database, which was also developed by Mr. Ben Gann, this prolific SQL database writer and developer. I want to take a quick, rather brief look at system databases and give you a little window of the databases that are part of SQL Server. For every installation of SQL Server, it doesn't matter whether it's on site or at your home or a company somewhere in the Netherlands, as long as it's a SQL Server installation, it must come with these system databases. Now, four of them are visible: master, model, MSDB, and tempDB. But there are several others that are not visible. We won't get into those. However, for this demonstration, let me just make a very quick mention of the master database. The master database is mandatory. If it is not present, SQL Server will not start. Beyond that, I don't need to say anything else about the master database. Anything you need to know, I can always make a reference to printed material, a book, and so on, and you can learn. The model database is, as the name states, it's a model. It's a template. Anytime you create a database, whether 1, 2, 100, that database that you create is created on the basis of this model. In other words, it's a template for all databases that the user creates. As a result, if you create an object inside that model, because you are allowed to create tables and create views and so on and so forth. If you allow those objects that you create on a temporary basis to remain in that model, you must be aware that any database you create thereafter will incorporate those objects, particularly tables. So if you create a table in the model and you call it table A, and then you don't delete it, but leave it intact, and then you go on and create a database later on, maybe 2 databases, 3 databases, 4 databases, each and every database that you create will incorporate that table that was left in the model. So be aware and be careful. The temp database is, as the name implies, it's a temporary database. You can create objects within that database, but don't create objects and leave it there with the idea that it's going to remain intact. Because the moment you shut off your server, your physical server, that database goes. It's gone. Once the database, the system, the server is restarted, the temp database is recreated. But it does not recreate with your temporary files. It only recreates with the system files that Microsoft has embedded. So that is something to bear in mind. So at this point, I need to demonstrate how you create a database using um, Management Studio. Then I will show you how to create a database using code. In other words, you're going to actually write transact SQL code to create a database, because you must remember that the entire purpose of this course is for you to learn structured query language. And in order for you to learn structured query language, you need to learn the syntax of the language. You need to learn the language itself, the clauses, the commands, and write code. And that's how you learn. So let's move on. Okay, let's begin by demonstrating how to create a database using Management Studio. The first thing we need to do is to ensure that Management Studio is open. At this point, I'm currently running the database engine called SQL Express. And we need to go to Object Explorer, select Databases, right-click Databases, select New Database, and once that new database dialog window opens, you simply type in the name of your chosen database where it states database name. So in this case, I'm just going to call it TestDB. Click OK. And there we have it. Now if you look again under Object Explorer, under Databases, you'll see one database, and that is the one that was just created, called TestDB. This is the only user-defined database under this engine. There are system databases, as there always will be. However, we're not dealing with the system databases here. We're just looking at the user-defined databases, of which there is only one. So that demonstrates how you create very rapidly a database using the graphical user interface of Management Studio. The act of creating a database here is rather quick, and it does not entail anything beyond what we just did. There are quite a number of arguments that is associated with the database. However, by default, Management Studio takes care of all that if you're using Management Studio to create the database. However, when we create another database and we use code, where you're actually typing in commands, you will have to be familiar with those arguments and embed them in your code. And we are about to demonstrate that in 1 second. Okay, let's begin. There is something I need to demonstrate rather quickly. It's associated with the first database that was created using Management Studio. As I mentioned before, there are several arguments that's associated with a database when you create it. And we didn't have to deal with them simply because Management Studio by default takes care of them. However, when you create a database using code, you've got to be aware of those arguments and take care of them in your code. So one of them is the location of the database file. And in this case, I'm using the SQL Express database engine. So the location of that database file, called a primary data file, and an associated log file called, well, LDF. The location of those files will be here. The data file goes here in the data folder. The log file goes here in this log folder. And the default for SQL Server is this path right here. It is C, Program Files, Microsoft SQL Server, and depending on the number of instances or database engines you are running, it will be under that specific engine. In this case, it's MS SQL 16, and then a subfolder called MS SQL, and then you will find it in another subfolder called Data, and also another subfolder called Log. And that is what I wanted to mention. Now, when you create the database using code, you're actually functioning as a programmer now, a structured query language programmer. You're writing statements. You have to be aware of these arguments and take care of them. One of the first things we need to do is to, well, in my case, I choose to do it. You can place your data in the default folder, but I don't want to do that. I just want to make a separate data folder and a separate log folder for the data that we are about to have once you create the database. So I have here a little script where this statement here, create database, and then you specify the database name on second line, on primary, and then there's this grouping where all the arguments are listed, will be executed, and it will create the database. However, I first need to create this folder and this folder, datas and logs. So I'm simply going to go here to the command window, and that will take me to my user profile. So as you can see, it's root directory C:\users / my user ID McKen, and I'm gonna just get out of that / and go to the root. Now I'm gonna clear the screen, and as you can see, I already have a SQL data, or SQL underscore data, and SQL underscore logs folder that I utilize to store my primary data files and my log files when I run my database instances, my database engines. So let's go ahead and create two separate folders. So I'm just gonna make a directory called datas, and make a directory called logs. There we are. And looking at it, we can see the logs folder here and the data folder here. Okay, so we've added two new folders. Now, data and logs. Now, normally, I have this new query window open, and I would simply do this. Create I use the create keyword, and you specify what you want to create, and it would be database, and then you specify the database name. And once you do that, you simply hit F5 or the equivalent execute button, and it goes and it creates a database. In this case, it would be short-sighted because it would not include all of the necessary arguments that are mandatory for a database in SQL Server. So let me go back to the script, and we have a database called BooksDB, and I'm going to go ahead and walk you through this so that you can understand what each line means. So the first line, as I said before, is to create the database. Create database, we're calling it BooksDB. Now the next statement says on primary. So primary is a file group. It's a logical container, and within that file group called primary will be the file name here. But if you notice, the file name includes not just the root directory where the operating system resides, but also the data's folder, and within that folder is a file called books.mdf. The .mdf tells us that is the primary data file. And the first line here, where it says name equal books in parentheses, that is the logical name that SQL Server uses internally to reference the file. But the actual data file is simply called books.mdf. You'll notice that the name here does not have an extension, whereas the books.mdf, the data file, has an extension, MDF. Originally, MDF meant master data file. However, I guess for political correctness, they decided that it would be best simply to refer to it as primary data file. Simply because if you needed to have additional files, and in real production databases, you don't have simply one data file, you have many, so that you can spread the database as it increases in size over different partitions, different drives, and so on. And the additional data files would be named NDF, N as in Nancy, D data F. And if you had, say, 3 additional files, it would be NDF1, NDF2, NDF3. But the very first one, the primary, is MDF. So when the thought occurred that if you call the first one master, then the second would be slave, it was decided that it was not politically correct, so they just decided to drop that, but they retained the MDF and simply call it the primary data file as opposed to NDF, which is the secondary data file. So another important note on the MDF file is that it is the file that stores the actual tables of the database, that stores the actual objects that you create, like views, stored procedures, so on and so forth. Those are uh, scripts that you write that will execute. Um, we'll get into those later. For example, if you have a process that occurs more than once on a daily basis, it wouldn't be feasible for you to go and write a script every time you need to get it done. So you simply write one script, call it a view, and you execute it as you need to. So we'll get into that. Now, the second file that we're talking about that must be included, because there's a minimum of 2 files. You must have the primary data file. You don't necessarily need to have secondary data files, but you must have a primary data file. But in addition to that, the other file that is absolutely mandatory in SQL Server is the log file. And the log file has an extension called LDF, Lady Dawn File, LDF. And the LDF file is very, very important, because if you're running transactions, if transactions are occurring, remember your database is just not, well, you have databases that are static, but most databases, as far as production goes, they're dynamic, period. I mean, they're functioning on a daily basis, they're living things. So if a system crash, you lose power and your UPS goes out, whatever. I mean, I've worked at places where the UPS actually burned up. So how do you recover your transactions? How do you recover the processes that was going on in the database? Well, you go to the log file, and that will help you to recover the transactions that were occurring. So the log file is very important. So again, just to recap, in every database on the SQL Server, there must be a minimum of 2 data files. The primary data file with the extension MDF, and the log file with the extension LDF. And the other arguments are, as I said, the logical name here is called books. The database is BooksDB, but here the logical name is books. And that is the name that SQL Server uses internally to refer to the system, to the database, to the data file. And then you have the size, the initial size of the database. You're telling it to be 4K. The max size is unlimited. Hey, sky's the limit, buddy. You can grow as large as you want. But the growth rate is got to be 1K. Okay? So, the growth rate can be specified in kilobytes, or it can be specified in percentages. In the log, it is specified here as a percentage. Alright, with that having been said, again, the file name for the log is here, book underscore log. It's traditional with SQL Server that the log file is always you always have an underscore appended to the end of the name, and then you add log, and then the extension. And books underscore log is the logical name that SQL Server uses to reference um, the log file. So let me be books. Let me be consistent here and add S. Okay. Oh. All right. Now that we've done that, let's execute this. Remember, we've already created the data folder and the log folder on the C drive at the root level. So we should have no issues with this. But just for the heck of it, I'm having problems with this key. Okay. So okay. Execute. Okay, so it executed successfully. So that's curious. Something just occurred, and I need to look into that. When I attempted to run the query, the system responded by asking me to connect to the database engine, and I still am connected to the database engine. So that was curious. I need to look into that. In any case, so we've just demonstrated how you create a database using code. So if you look under Object Explorer, the database will not be visible until you actually do a refresh. That's one of the quirks of Management Studio whenever you use the query window. So let's refresh, and there we are in all its glory, with all of the objects that has been created by default, but none of those objects, whether tables, database diagrams, etc., none of them has anything included that we created, because we have not yet created anything. The database, for all intents and purposes, is essentially empty, except for a few system files, views, so on and so forth. The next step will be to actually design a database, and that is install the tables for the database. The database, remember, is just a container. Now we have to populate that container with the tables, and once we populate the database with the tables, then we have to populate the tables with data. So when I say we have to design the database, the act of actually putting all the tables together is what I mean by designing the database, because there are several considerations. When you create a table or tables, they have to meet a standard known as NF, or normal forms, of which there are 4 normal forms. And we will be getting into that in our next video. Thank you for bearing with me, and I look forward to seeing you in the next video. Thank you.